All right, we are ready now for Geometry Note 6.4, Properties of Special Parallelograms. This one reads, a second type of special quadrilateral is a rectangle. Well, the first type being a parallelogram. Continue reading, a rectangle is a quadrilateral, meaning it has four sides, with four right angles. Rectangle ABC is drawn for you. Notice the four little boxes in the corner. That's what a rectangle is. Properties of rectangles. We have two theorems. The first one, 641, reads, if a quadrilateral is a rectangle, then it is a parallelogram, which means that all of that stuff we learned about parallelograms also applies to rectangles, such as opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary. All of that stuff about parallelograms also applies to rectangles. The second theorem reads, if a parallelogram is a rectangle, then its diagonals are congruent, which in other words, from point B over to D, that length is the same as from A to C, that length. Those two diagonals would be congruent. Now remember, in a regular parallelogram, it was just the diagonals bisected each other. They weren't necessarily congruent. But now in a rectangle, they will always be congruent. And down below, it kind of repeats what I just said. Since a rectangle is a parallelogram by theorem 641, a rectangle inherits all the properties of parallelograms that you learned in 6.2. So if it applied to parallelograms, it also applies to rectangles. With that said, here's an example. Third slide. A woodcutter constructs a rectangular picture frame. So JK is 50 and JL is 86. So JK, let's mark that. JK is 50. It's right there. 50, that side is 50. And JL, so J to L, that's the diagonal. That's 86. 86. Find HM. So H to M would be this length here. Well, first of all, if you know that JL is 86, that's one diagonal. That means the other diagonal, which would be K to M, would also be 86 because it's a rectangle and diagonals are equal. But also remember that a rectangle is a parallelogram, and in parallelograms, the diagonals bisect each other. So in other words, HM is half that length. So half times 86 is 43. And that would be my answer. So each of those little halves in there would be 43. The next one, carpentry. The rectangular gate has diagonal braces. Find HJ. Well, this is kind of a simple one. We're going to find HJ. What's this top side? Well, it looks like the bottom side is 48. So it's a rectangle, so the top would have to also be 48. And 48 would be my answer. This problem has nothing to do with the diagonals. We save that part for the next slide. This slide, everything's the same except it says find HK. So H to K, there's H and there's K, is that entire diagonal. Well, if you look, this 30.8 is just half. And remember, the diagonals bisect each other, which means they cut them in half. So if a half is 30.8, I want to find the whole, I would multiply it by 2. And that would be 61.4, 0.8, no, 61.6, sorry. 61.6. 30.8 times 2. All right, let's move on to the 6th slide. Now talking about a rhombus. So we've been quadrilateral to parallelogram to rectangle, now to rhombus. A rhombus is another special quadrilateral, quad meaning 4 sides. A rhombus is a quadrilateral with 4 congruent sides. So it almost looks like a square. It's a square without the right angles. It's kind of a square tilted over. 4 congruent sides. Here's some theorems about it. If a quadrilateral, here's the first theorem, 643. If a quadrilateral is a rhombus, then it is a parallelogram. In other words, a rhombus inherits all of those properties from parallelograms. The second theorem, 644. If a parallelogram is a rhombus, then its diagonals are perpendicular, which means I can put a little box in the corner. Perpendicular. They meet at a right angle. And the third one down there, 645, if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. Meaning, all 4 of my angles are cut in half. Like if you look at angle B, for example, it's divided up into 1 and 2. Well, those are both equal. Angle 1 would equal angle 2. And that would be the case for all 4 of them. With that said, let's check out this example. TVWX. TVWX is a rhombus. Find TV. Well, that's not short for television. Let's go find it. TV would be this length on this right-hand side. Well, do I have another side somewhere? Well, I see that the bottom is 13b minus 9, and the top is 3b plus 4. Now remember that all 4 sides are congruent, so I'm going to write the equation 13b minus 9 equals 3b plus 4. And I want to solve this for b. So I go in, if I subtract 3b, I get 10b minus 9 is 4. And if I add 9, 10b would be 13, or b is 13 tenths. So if I put in that answer into 13b minus 9, I plug that fraction in, I have 13 times 13 tenths minus 9. Whatever that simplifies to. 169 over 10 minus 9 would be the same thing as 169 over 10 minus 90 over 10. Oh, yeah, 90 over 10. That would be 79 tenths. So what that means is the bottom is 79 tenths. So the top would also be 79 tenths. The left side would be 79 tenths. And the right side, which is what I'm trying to find, TV, is also 79 tenths. All 4 sides of a rhombus are equal. So when you find one side, you automatically find all the sides. Let's take a look at another one. Hopefully this time we won't get a fraction. This one reads CDFG is a rhombus. Find CD. Well, find CD, and that's this side, kind of the top left-hand corner. I need to find A first. So I'm going to write 5A equals 3A plus 17. Those two sides are congruent. I can actually mark them with a tick mark. Let's solve for A. If I subtract 3A, that's 2A, is 17. So A would be 17 halves. And now I need to plug that in to, let's choose the 5A because it'd be easier. Plug it into 5A and take 5 times that A, so times 17 halves. That would be 17 times 5 is 85 halves. So that means that this side is 85 halves. This side would be 85 halves. Every side would be 85 halves. Or what would that be? 44.5 if you want it as a decimal. That's easier for you. 44.5. Again, in a rhombus, if you find one side, you found all the sides. Let's look at another example. TVWX is a rhombus. Find the measure of angle VTZ. Let's go find that angle. V to T to Z. It's this part right there. V to T to Z. Well, how could I find that angle? I know it's going to equal 5A minus 5, because remember these angles bisect each other, so those two angles are the same. Well, I need to solve for A. And I'm going to use this part right here, which is going to this angle. And if you remember the theorem that said if you have a rhombus, the diagonals are perpendicular, which would mean that 14A plus 20 is perpendicular, so it equals 90. So if I subtract 20, I get 14A would equal 70. Divide by 14, A would equal 5. Yeah, that's right. A is 5. So now that I know A, I'm going to plug A into this up here, this 5A minus 5. 5A minus 5. And I'm going to substitute in 5 for the A. So I get 5 times 5 minus 5. Lots of 5s there. Which gives me 25 minus 5, which gives me 20. In other words, this angle is 20. So then this angle is also 20. And 20 would be my answer because that's the angle VTZ, 20 degrees. Let's look at another one. I'm sorry, I wanted to skip this one. So put an X in this box. I'm sorry, didn't want you to include this one. I'm going to go to this last slide. We've done quadrilaterals, onto parallelograms, onto rectangles, onto rhombus, now onto the square. It reads, a square is a quadrilateral with 4 right angles and 4 congruent sides. In the exercises, you will show that a square is a parallelogram, a rectangle, and a rhombus. So a square has the properties of all 3. In other words, if there was a rule about a parallelogram, it applies to a square. All those rules about rectangles, it applies to a square. And all those rules about a rhombus, they apply to a square as well. So we will practice some of these in the book. Good luck. Thanks for watching.